Hello everyone, welcome to another video session class. So in today's class we will study about reactions of pyridine and uses of pyridine, that means medicinal uses. Okay, so let us just start reaction first. Electrophilic addition to nitrogen. So there you can say this pyridine undergo electrophilic addition to nitrogen because nitrogen is having extra electron. So in acid protonation will take place, that means from HCl H plus will be released and that will be taken up by this nitrogen to form pyridinium chloride. Okay, so this is the reaction, just a basic property, that means it can act as base. Then next, N-alkylation. So that means N-alkylation means there will be addition of alkyl group to the nitrogen. So here also this from CH3I methyl iodide, this methyl group directly attached to this N nitrogen to form 1-methyl pyridinium iodide. Okay, so this is these are the two electrophilic addition to nitrogen. Okay, addition reaction to nitrogen. So next we will see electrophilic substitution to carbon. Okay, so here you remember at third position mainly, so numbering we know 1, 2, 3. So at third position mainly the electrophilic substitution is favored. Okay, favored. So the possibility are there, for example in the 2 position, third position, third carbon or fourth carbon, but the favored position is C3. Okay, why it is? Because nitrogen is electronegative, so positive charge on nitrogen destabilize the structure. So if there is any positive charge on the nitrogen, it will destabilize the structure. Here attack at C2 and C4, you just see C2 and C4 attack. So C2 means here in this position and C4 means 1, 2, 3, 4. Okay, in this position generates N plus intermediates, that means positive charge on nitrogen which will destabilize the structure. So in C2 and C4 you see you in the resonating structure you are getting N plus here and N plus here. Okay, so there that means it will generate, if the electrophilic attack is at C2 and C4, it will generate N positive, and which is less favorable. Only C3 is favorable. Why C3 is favorable? You just see all the resonating structure, you will not get any positive charge on nitrogen, there is no positive charge on nitrogen. So only C3 is favorable because it cannot generate N plus intermediate. Okay, so that you have to remember. So next, that about electrophilic substitution takes place at C3 position we know. So reactions are nitration. So simply with HNO3 at concentrated H2SO4 under heat condition, you will get at C3 nitro group will be attached. Okay, that is electrophilic substitution to carbon, substitution reaction to carbon. So 3-nitropyridine. Then sulfonation. So pyridine is very resistant to sulfonation using concentrated sulfuric acid or oleum. So simply with oleum and H2SO4, it is not going to get sulfonated. Okay, addition of mercuric sulfate, so that HgSO4 as a catalytic quantity, as a catalyst, allows smooth sulfonation. So this HgSO4 as a catalyst concentration, it will just sulfonate the third position. So you will get 3-sulfonic pyridine. So you can write this name of the structure as a 3-sulfonic or 3-sulfopyridine. Okay, 3-sulfopyridine. Next, electrophilic substitution to C again, the carbon. So halogenation reaction. So here 2-bromopyridine is produced in good yield by the action of bromine in oleum. So in action of bromine in oleum, you will get 3-bromopyridine and 3-chloropyridine, that is this product. Okay, this product can be produced by chlorination in the presence of aluminum chloride. So if you just do chlorination in presence of aluminum chloride, it will give 3-chloropyridine. Okay, so that is the 2 halogenation reaction I have given. So this is the pyridine, you do bromination in presence of oleum, so it will be 3-bromopyridine, chlorination in presence of LCl3, it will give 3-chloropyridine. So next reaction, that is nucleophilic substitution reaction. So why pyridine undergoes nucleophilic substitution reaction at 2 position? That is one question. So C3 and C2 may be possible position which undergo nucleophilic substitution reaction, but only C2 is favorable. So you just see attack on second position, that means 1 2, okay, this one gives more stable intermediate containing negative charge on nitrogen. Okay, so attack on second position will generate a n negative intermediate, okay, the negative charge on nitrogen, so which will ultimately do what? It is very much stable. But since since more electronegative nitrogen atom hold negative charge in one of the resonating structure, so this is the resonating structure obtained from the attack of nucleophile at C2, that means this one. Hence the nucleophilic substitution in pyridine at position C2, that means this position, will always be favored, okay, because here in any other structure you will not get any n negative, that is negative charge on nitrogen at the C3 attack, okay, but at C2 attack you will get one n negative. So that is very much essential for stabilization of nucleophile, okay, because it is adjacent to nitrogen, and nucleophile, we know it loves what? Nucleus, that is positive charge, okay. So that nitrogen will withdraw the withdraw electron from the second position, okay, from the double bond, and nucleophilic attack will be more easy, okay. So next, nucleophilic substitution reaction. Example of nucleophilic substitution. So reaction of pyridine with sodium amide or sodamide at high temperature. So it is also known as Chichi-Babin reaction. So you have to remember. So this pyridine, this sodium amide or sodamide in presence of ammonia, so it will give pyridine to amine. So at second position or C2 position, the reaction is favored, nucleophilic substitution reaction. Mechanism, just this NH2 from here. So it will attack the second position, okay, but this will withdraw the electron and will generate a positive charge here. So there is NH2 will attach, this hydrogen will leave, so ultimately we are getting the pyridine to amine. So it is very simple mechanism, okay, just electron delocalization. Next, nucleophilic substitution reaction, again another example, that is reaction with phenyl lithium, okay. Pyridine reacts with phenyl lithium, an organometallic compound, so this is phenyl lithium C6H5Li, to give 2-phenyl pyridine. So at you see this one also a nucleophilic substitution reaction, so substitution occurs at second position, okay. So this one the reaction. Then next, pyridine as nucleophilic catalyst. So here in this reaction, this pyridine is acting as a catalyst, okay, just a catalyst. That means it will just faster the reaction and complete the reaction, and after the reaction it will just eliminate out. So used as catalyst for acylating phenols, okay. So phenols acylation will be possible in presence of pyridine, okay, alcohols and amines, phenols, alcohols and amines using acyl chloride and anhydride. So you can use acyl chloride or anhydride to complete the reaction. Then next, reduction reaction. So reduction reaction, that means addition of hydrogen. So you either do with palladium catalyst, or in sodium and methanol you will get piperidine. That means all the unsaturation will be gone and you will get fully saturated compound with in every position there is addition of hydrogen, okay. So you just see here hydrogen 1 hydrogen is added to get the ring piperidine. So it is 6 member ring nitrogen containing fully saturated compound piperidine. So medicinal uses, next we will see. So it is an antitubercular agent, it is used, okay. So isoniazid, the compound, this is the compound, it is containing pyridine as a ring, okay. Then next, it is also used as antibacterial agent. So for example, sulfa pyridine, sulfasalazine. So this see one structure which is containing pyridine as a basic moiety, okay. Then next, anticholinesterase agent, for example pyridostigmine, so which is used, you already know, it is used in myasthenia gravis. So this is the structure, this also containing pyridine as a basic moiety, okay, within its structure. So next, proton pump inhibitors like omeprazole, lansoprazole, pantoprazole, rabeprazole used in peptic ulcer, okay, for PPI, okay. So This all PPI are the derivative of this pyridine. You see, this is the pyridine ring XYZ. You just change the functional group, you will get omeprazole, lansoprazole, pantoprazole, rabeprazole. Okay. So next, another use that is, it is this pyridine is the basic moiety of vitamins like B3, okay, nicotinic acid or nicotinamide, and B6, that means pyridoxine, okay, or pyridoxyl phosphate, okay. So which are used for various vitamin deficiency disorders. For example, here it helps in digestion and digestive system health. So as a aid, as a nutrient, or as a vitamin supplement, these are used, okay, for maintaining our health. So you have to remember, it is also the basic moiety of some vitamins like B3 and B6. So you just see, this is the pyridine structure, this is also the pyridine structure. So I hope you have understood. Thank you.